Hey everyone, in this video we're going to go over pattern matching. Now, I would preferably do lists right now in a YouTube series, but lists and pattern matching go very well together. So I'm going to start off by doing pattern matching. It's going to be a very quick introduction. You're going to see the real power of pattern matching when we do lists, and also user requested that we do pattern matching or some exposure to it. So we're going to do this now. It's going to be a great introduction, and when we get to lists, we'll be able to really use it. So pattern matching is just another way of writing better code in terms of if-else, conditional statements. Now, we're going to find out later when we get to lists that pattern matching is a lot more than just writing if-else statements. But for our sake and what we've learned so far, it's a great if-else substitute. So what I have right here is code I already wrote out. It's a function that says is 0. So if the value that we pass in x is 0, then we'll print out like true or false. And remember, or not remember, but we can't do print bool. That's not a supported function. We can roll a print string though, so that's why our return type is of type string. So let's see, what is this saying right here? So we're saying is 0, we passed in an integer x, we're going to output a string, and we say match x with 0, true, 1, false. So if you have to take a guess on what this is doing, it's saying, okay, I'm taking in a number, and we're matching x with. We don't really know what that means, but okay, I think it's saying maybe if one of the following happened. If it's 0, then we're going to give the value true, and if it's 1, we're going to give value false. Let's run it. You're going to get barked at by the compiler. It's going to tell you blah blah blah. This is not exhaustive. We'll go over that when we go over lists. Or actually, we can go over it now, but alright, and we get the value true when we run it. So that's very neat. So in this kind of what it means not exhaustive is to mean that we're not running through all the possibilities of what x could be. And it says here's an example of what x could be. It's 2, and we don't have 2, and that's right. Like we only have begin at match x with 0, 1, and we don't really account for anything else. I mean, we could assume it's a binary digit, but let's run 2. And that's another important thing. When you have a compiler and you get a warning, your code still runs. It could still work. It's just it might run into problems or not behave as expected. And error says your code cannot run. So warning is just saying, listen, this is not properly considered. It may be best to revise it. So let's try to run 2 for, I don't know, the sake of seeing what happens. And this is an error, right? Fatal error. So it kind of warns us, and then we don't listen to its advice. It gives us an error because when we pattern match, we don't get 2. We don't have 2 in here. There's no case for it, right? It's like we have an if statement. If it's 1, if it's 2, if it's 0, if it's 1. But what happens if it's 2? Nothing. We don't really know. Okay. Well, I know how to fix this. Let's just say 2. Well, it's not 0, so it's false. And since it's an expression, we do our double semicolons. I think you could put them. Can you put them over here? I don't know. Let's break the boundaries here and find out. Oh, okay, yeah, you can. All right. So hey, but now we have 3, but we never considered 3 according to the compiler. But when we run 2, it works. So well, then what if I pass in 3? So this argument can continue forever, or it'll be a very long video, infinitely long. So instead, if we only care about 0, we could say the following thing. We could do this little dash, what's it called? Underscore? I think it's called underscore. Name's totally slipping me right now. So I think it's called underscore. Alright, we compile, no warnings, alright, and we run it, and we get false for 2, alright. Let's do like this number, 172. We run it, and false again. So what is this underscore telling us? It's saying we don't care what the expression is, false, right? So this match with And this is syntax, right? We have a variable, we say match, variable name, I think I have it right here, yeah. Or we could do begin end, we'll get to the future videos, just syntax. We say match variable with true 1, false 0. So this is an example of true or false, and this is another return type. You can really do it to anything as long as they're consistent. So I'll do a future example right now. But anyway, it goes about this in a linear way. So it starts with the first guy. It says, hey, is the first guy what we want? 0? Yeah, if it is, then we output true, and then we're done, right? We don't need to bother with anything else. I mean, this can go on 100 lines. We don't care. But hey, if it's not 0, then we get here. Underscore means I don't really care what x is, just output false, and that's what it's doing. If it's not 0, it doesn't care about the rest, it's false. Let's try to do an inconsistent type here. Say 5. It should give us an error right off the bat, and it does. So these, just like if statements, these have to be consistent. So that's pretty much it for pattern matching with what we know. When we get to lists, it's a very powerful thing. I just want to introduce it right now. In our next video on lists, we're going to go over lists, and we're going to link it to pattern matching. So it's going to be a powerful video. Stay tuned, guys. Thank you very much.